Hey everyone, another day, another DSA problem. So today let's look at 1358, number of substrings containing all three characters. This is today's daily problem, so let's just take a look at it. Okay, so it says we're given a string S consisting only of characters A, B, and C, and they want us to return the number of substrings containing at least one occurrence of all of these three characters. All right, so the problem is very straightforward. It's simple, so let's just check it out how we're going to solve this. Okay, so it's given. A string S is given, and we are guaranteed that it only has these three characters, A, B, and C. So the goal is to get the count of the number of substrings that contain at least one A, one B, and one C. So let's look at an example, the same example which they have given. So this is the string ABC, ABC, and the answer is 10. How did we get 10? Let's just try it out. Okay, so the minimum substring here, which has all the characters that we want, at least one occurrence of them. So let's write this down. We have ABC. Then I can extend that, right? I can extend it to this side. So I can make it ABCA, and then I can make ABCAB, and then the whole string ABCABC. Okay. So what if I started from here though? Okay, so I start from here, and again, I have another string. So that's BCA. I can extend that. So BCAB, BCABC. Okay. So maybe let's use another color, and then another minimum substring, which has all three characters, would be this one, right? So let's write that. We have CAB, then we have CABC. Now, if I want to go and check for another substring, we have this one. So this has all three characters again, right? So that's ABC. So if we count this, we have 3 here, 3 here, 3 here, and 1 here, which amounts to 10. So you guys see what the problem is actually asking for. And yeah, we got 10. So what is a brute force naive approach to solve this? So we want substrings and we want to count certain things in the substring. So yeah, let's just do that, right? So let's generate all substrings, like iterate through all the substrings. We'll start adding characters to a set because repetition is still fine for us because we want something which has a count of at least one, right, of each of these characters. So we'll add it to a set, and anytime that set reaches the size of 3, I know that I have a substring which has at least all the required characters that I need, one of each. So then I will add 1 to the answer, and I'll just continue checking substrings and then continue to increase the size. So what happens here, to generate all substrings, it takes O of n square, and then we're using a set, but given that we are guaranteed that we have only 3 characters, right, A, B, and C, this will be, it's O of 3, O of 1, basically. So this is O of 1. Now I'm just going to go ahead and write this code. This is not acceptable on LeetCode because obviously it's the brute force approach, but just to kind of get an idea, we can go ahead and write it. So this is a string right now. I'm going to go ahead and convert that to a list. Then I can take length of s. Let me take count or answer. So what was I going to do? I was going to iterate and just go through all the substrings, right? So I'll do for I in range n, and then let's have something like a present set, and then we'll go j in range I to n again. Okay, and each time I'm going to add it to the whatever is present. Present dot add, what was this? S of j, and then I'm going to go ahead and check if length of whatever is present is equal to 3, then I know that I've found a substring, and I can go ahead and was count, right? Yeah. So I can add 1 to count, and I want to continue. Like even if I increase the size of the substring and I still find valid substrings with at least 3, then yeah, then I'm going to go ahead and increase count again. So in the end, I should just return count, and this should work. Yeah, it works, but I'm not going to submit it because it's going to give it TLE. But you guys get the idea. This is the brute force O of n square solution. So let's go ahead and check what our optimization is. Okay, so as we saw in the earlier example, right, I was expanding. So basically what I did there itself was the answer. So let's just check this out. All right, I've just written whatever the algorithm is, what we're going to do and follow here. So let's check this and we'll look at an example. So we're going to use a sliding window, as in we're going to have 2 pointers. And what we want to see is in this window, how many characters, like the characters, what are the frequencies of the characters that I have, right? And I need to have all of these 3 characters. So that's one thing. So I can tell that I can use a window and it can go on increasing this window, something like that. So here's what we're going to do. We're going to use a sliding window. And we're going to have like our character frequencies, right? And we're going to start from a point. We're going to start increasing the right pointer until our window consists at least one of each of these characters, 1A, 1B, 1C, at least, right? And when I do get that, what I'm going to say is, hey, if I have everything in this substring already, then anything I just add to this is just an additional new substring which I can create. So once I have a ready substring, I can add everything else to it and just make one more substring, one more substring. So yeah, let's see what happens next. Okay, so we're gonna keep expanding it until we see that we have at least 3 characters. And once we know that we have 3 characters, any longer substrings which start at L are valid. So what does this actually mean? Let's take this example here, the same one. No, it's a different one, sorry. A, B, C, 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 and B. So I see that the first valid substring here is ABC, right? And then I see after I create ABC, what does that mean? I have one substring, which I'm getting here. But then I can also extend this because that still consists of ABC. Then I can extend this and then I can extend it to this. So once I find this, along with this being like adding to one substring, I can add all of these as well to kind of gradually increase that substring to make new substrings, right? So this is given by the formula n minus r. And let's see why that is. So there are 6 characters here. The size of the string itself was 6, right? And then 1 was coming from itself. And then there were 3 additional substrings that could have been formed, right? So if I do 6 minus the position of r, which was at 0, 1, 2, 6 minus 2 is equal to 4. And exactly, I was able to take this, then add this, then add this, then add this. So that gives us 4. So this is the formula that we will be using. It's basically telling us the same thing. Like if I can form with this, like from the right side, like how much more can I add? Like starting from L, if I have created a substring, how many more characters, like how many more strings can I create starting at this point? So I know it kind of looks like we're just adding from the right, but no, I will show an example to show why that's not true. So yeah, basically after doing that, I'm going to go ahead and like increment my L pointer to reduce the size of the substring, because if I have everything in this, then let's see if I can form another one. Let's see if I can form another one. You want to try to like check all the substrings again, right? So as long as it's valid, you're going to keep like incrementing L. Okay, so that's the next step there. Now let's take an example here where our ABC is actually present in the end. Okay, so what's going to happen here? This is 0, 1, 2, 3, and 4. We're initially going to start from here. Then I go to the first point of like first index, second index, third index. I'm still not finding like one occurrence of each of these until I go to 4 though. That is when the count of A is 3, the count of A is 3, the count of B is 1, and the count of C is 1. At least all of those are like greater than 0, right? Everything is 1. So how would this add up, right? So what would happen in this iteration would be, I would be at the index 4. And once I reach that index, I'll have a while loop, right? So I'll say while like all these characters, they are greater than 0. Like they have an occurrence of at least 1. And when they do have it, what do I do, right? So to my answer, I will be adding n minus r. And in this case, n is equal to 5. And my r it's at 4. So 5 minus 4 is equal to 1. Okay, so answer is now equal to 1. But then, remember, we take this step where we shrink the window and we increment L, right? So then my L pointer will go here and I'll be like, hey, does this substring still count? And yes, it does. So again, this will do n minus r, and r is still at 4, right? So again, 5 minus 4 is going to add another one. Then I'll go here, and this is still valid, so it's going to add another one. That's still here. But once I come here, if L is here, then obviously when we're incrementing L, we're also decrementing the count of the frequency of whatever character was there at S of L. So that would have made A would have become 0 now, and this condition no longer holds. Our answer would be 3. And if we go over here, this is the same example. Yes, the answer is 3. Yeah, so I hope you guys understand. Let's just jump to the code so we can check that out. So first thing we were doing was we were having something like frequencies, right? So I'm just going to go ahead and write all of these, like A frequency was 0, then we have B's frequency was also 0, and then we have C, whose frequency is also 0, right? And we can take like our left pointer and our right pointer, which are both going to start at 0. We can have an n, which is length of s. So let's just do this for r in range n, okay? Because r is anyway going to keep increasing. It just depends on L what we're going to do, right? So I'm going to do frequency of whatever is there at r plus is equal to 1, okay? Now I've increased that frequency, so I know till here how many counts of like all these characters do I have. And let's do that check. While frequency of A greater than 0 and frequency of B is also greater than 0 and frequency of C is greater than 0, what do I want to do? As we talked about that, like, sorry, I forgot to keep something like an answer. So to answer, what was I doing? It's going to be equal to this plus all the other ones which I can add and create new substrings. So that was given by the formula n minus r, right? And now I want to increase my L pointer. So before increasing that, I want to access that value and remove it from my frequencies. So I'm going to do frequency of S of L is decremented by 1, and then L plus is equal to 1. So by the end of this, I should be able to have this count of how many substrings were actually formed, and this is stored in our answer. So we just go ahead and return answer. We discussed the time complexity of this is O of n, and the space complexity is O of 1 because we're just storing 3 here. Let's see if it works. Okay, it does work. And yeah, so this is the optimal solution for this problem. It's nice, actually. So yeah, happy coding, everyone.